Good afternoon, everyone. I want to confirm if everyone is sharing me clearly. Can somebody confirm that?
Yeah, it looks good.
Okay, thank you so much. I want to welcome everyone to the final class of the semester. Of course, today is your official, uh, final day of teaching at the university. And of course, I'm actually going to use today's class to walk us through the final exam practice question. And not only that, I'm going to tell us the area of concentration, and I'm going to also give information about what are the materials that are required in the final. Among other information that I'm actually going to dish out that will make every one of you in a way to succeed excellently in this course. We actually started strongly, and I want situation where we're going to finish on a strong foot. So I've already shared my final practice questions. Of course, we have from problem one all the way. So as you can see, I'm actually rolling the screen right now. So all the way to problem five. And I think I already uh, sent an information on the announcement section regarding the area under concentration. I'm going to walk us through this just like the way I promised. Okay, going to walk us through this. Okay, so I'm actually confirming. And let me also say this. Uh, we're not going to have We're not going to use Haro software for the final. We're not going to use Haro software. Like I said, you do not need any statistical software at all. I'm actually going to provide Haro output, and of course, the question will be based on that. And I want to confirm once again if everyone is actually seeing what I'm projecting now. Is everyone seeing seeing what I'm projecting? Okay, thank you so much. Thank you for confirming that. So, there's going to be question that will come from the area of binary logistic regression, but of in a situation where you're given a table of outputs like this, you have the coefficient, the standard error, the z value, and the p value already figure out. They gave you all of that. And of course, they're trying to predict the probability of attrition based on the monthly income and over time. So what is the probability, okay, of attrition? I'm gonna say this again. So we actually building a model, okay? We're trying to identify our factors, that we actually are leading to what I call attrition. We want to consider monthly income, we want to look at the role played by over time. Of course, we all know attrition generally means a gradual reduction in the size or the number or the strength of something over time. And of course, in human resources, they refer to that as a reduction of employees in an organization. So reduction can happen due to resignations or retirement or even death. Or maybe employee leaving voluntarily without the position being replaced. But right now, even though we got a lot of factors that could explain that, but on this question, they want to look into the effect of monthly income and the overtime. And because attrition could occur or not, so that's why they fit in binary logistic regression. Now, the very first question based on the output is said, they let you know that pi represents the probability that the attrition response variable is yes. So pi here represents the probability that attrition is gonna take place. Of course, 1 minus pi, we actually mean it's not gonna take place. So if you take a look at the question right now, say write the estimated logistic regression model. There's something I needed uh, to consider here. When I say logistic regression model, there are two forms of that. Okay, we have a logit form, we have a probabilistic form. So here, I only give the probability form. Okay, this is a probability form. So what of in a situation where they also ask you to write the logit form? Okay, the logit form is actually going to be the log of odd ratio equal to the systematic part of the model. So based on the output that I have here now, okay, based on this output, so the estimated model is actually this. Is there any question about how I come across this? Is there any question? So this is the solution to the problem. Okay, the estimated logistic regression model. So this is a probability form. That's what I mean. And don't forget, you're actually going to put a cap on that. The cap means you're talking about the estimated. Another question I have: obtain the estimated log odd, okay, when both monthly income and overtime are zero. So what I would advise that you should do, because they talk about the estimated log odd, you need to first write the estimated log odd. Can you see that? That's the estimated log odd. Okay, this is having logistical regression in a log odd form that we also call a logit form. Now, based on what it said here, they said the monthly income, when the monthly income and the overtime equal to zero, okay, so all what you just need to do is you're going to plug in zero. I'm confirming to you in the exam, you're actually going to make use of scientific calculator. So the use of a graphing calculator is not allowed. I'm going to say that again. The use of a graphing calculator is not allowed in this exam. You are only allowed to use a scientific calculator. So make sure you come into the exam hall with a scientific calculator, a calculator you can trust. So at the end of the day, my logod is actually giving me that. Okay. Now, another question I have: what are the estimated odds of finding attrition when both monthly income and overtime are equal to zero? We know here we make use of the log odd, but right now they want you to remove the log. Be able to remove the log from a logit, you're actually going to perform a mathematical operation of exponentiation. Okay, so removing the log odd, I'm actually going to find the exponentiation, exponential that. Take a look at that. That's why I have that. So this guy now is the odd ratio, now equal to that. Okay, can you see that now? Now equal to that. That's what I mean. That is the odd ratio. So the odd ratio is actually this. Now the next question says, obtain the estimated odd ratio when overtime equal to zero. Okay, you want to find the odd ratio when the overtime is actually equal to zero. Okay, now what you actually going to do when the overtime is equal to zero, okay, you can just go into the odd form of that. Like I can come here, okay, overtime equal to zero, okay. I'm only going to get that it's going to be in form of a monthly income when the overtime actually equal to zero. So that is exactly, you know, and when the overtime equal to zero, it means I'm only going to be focusing on just a separate on the other one. So right now, and that's why you see here, okay, I have the exponential raised to power that, and I'm going to have that when I multiply. This is where eventually what I'm actually going to have. Okay, so that's what I'm going to have. So the estimated odd ratio when the overtime is that. Then we can also find the probability. Okay, if I have a model, this is a model, the log odd, this is in log odd. Okay, if I want to find the probability, that is I want to find pi. Okay, now uh you don't forget, want to estimate the probability of an attrition, okay, with over time, okay. Now, if you take a look at what I have here, okay, and if I let the overtime to be equal to one, okay, if I let the overtime to be equal to, when I say with the overtime, it means I'm keeping the other variable constant, the one that has to do with income, okay, I'm actually keeping that constant. That's why it's not going to be in the model. Initially, don't forget, in the model, we have both monthly income and overtime, but because they say we're focusing on the overtime and this guy, we can silent on that. So which is what you're seeing here. Uh, so if you take a look at this, I'm only considering the one that has to do with that. So if you take a look at what I have now, when I plug in one for overtime, also that was why I said over time equal to one by plugging one. So what do I have? I got that. Then if I have that, I just need to solve mathematically for pi. Okay. If I want to solve for pi, I'm only going to have this over this exponential raised to power that. Then I'm going to solve for pi. Eventually, the pi is going to give 0.51. Okay, so that's going to be part one of that. We're also going to have part two. Now, what if in a situation we are still on binary logistic regression? They gave you the beta null, they gave you the beta one, and they said the likelihood of yes for a given value of s is given as this. If this is given, okay, they already gave you this, okay. So which means they've helped you how to plug in all these values into the equation. Okay, they're giving you that, and they say that is the likelihood of yes. And the question now say, suppose s equal to 1, what is the likelihood of yes? So wherever I see x, I'm going to plug in 1, then I'm just going to use my calculator. And that's going to give me that. So whether s equal to 1 or s equal to whatever, you're going to make use of that. Okay, that would be the likelihood. That's what I'm doing here too. Can you see that? Just plug in s to be 2. S is actually replacing, 2 is replacing s. Now, another question now say, suppose that the two observations are made and that s equal to 1 for the first and s equal to 2 for the second. What is the likelihood of the pair outcome yes and yes? That can be independent. Situation where there's going to be independent, if all of us plug in when s equal to 1 into the model, you plug in when s equal to 2 into the model, and because they are independent, I can multiply the outputs. So when I multiply out, that's what I'm going to have. Okay, that's what I'm going to have. Even if you have three observations, even for three observations, where they're going to ask you maybe s equal to 1 for the first observation, s equal to 2 for the second observation, and s equal to something for the third observation, or what you need to do is to plug them in into the model, then multiply out because they are independent. Okay, in statistical theory, when events are independent, so what we normally do is to multiply the likelihood. So the problem one in the exam will be based on binary logistic regression, like I said. Is there any question from the audience before I go into problem two? So one of the problem in the exam, we focus on binary logistic that will look like what I just walk you through now. I need somebody to confirm from the audience if you are still hearing me clearly. Is everyone still hearing me clearly? Okay, thank you so much. Thank you for confirming that. Just like in a regular class, you can also talk by if you want to ask question or you need some kind of clarification. This is being recorded, and of course, I'm actually going to publish this. Now, I also want to confirm to you one of the problem in the exam we centered on multinomial logistic regression. Don't forget we use multinomial logistic regression when the nature of response variable is categorical and it has more than two levels and they are not ordered. So right now, they gave you a question that has to do with party identification, where we have the Democrat, we have the Republican, and we have the Independent. So we have three categories. The response variable, which means a member can be Democrat, a politician can be independent, a politician can be a Republican. And we want to believe that, these are not ordered. Okay. Now, we actually want to determine or you want to investigate factors that determine our party affiliation. You want to make use of, you want to consider predator like age, education level of the respondent. The education level of the respondent is categorical, is ordered. You want to talk about the income, and you want to talk about the expected. When I say income, I'm talking about the respondent family income. And of course, we want to talk about the expected votes in 1996. Now, I need you to pay attention. The coding has been done for you. You do not need to code anything. So now they've given you all of that. They run multinomial logistic regression and they provided the output. Please pay attention. We have the output right now. The output is going to be provided. We got three levels. Don't forget, when I was walking you through multinomial logistic regression in class, okay, don't forget one level will be referenced. Okay, and that's why here, it's like the arrow to reference Democrat, and that's why you are seeing in the output you can see independent and Republican. Okay, so when you got three levels, it's only two levels that will be reported, and which means the other level is reference. And the other level that was referenced is not as if it's inferior. It's not. So you're actually going to be looking into each of these relatively to the level that was referenced. Okay, so based on what you have right now, the question is now asking you, write the estimated multinomial regression model for both outcome categories, independent and Republican, because don't forget, these are actually reference Democrats. Okay, now the number B is interpret the slope for the income in the independent equation. Then they also wanted to interpret the slope for income in the Republican equation. Of course, there are going to be two equations. One we centered on independent, and the other one we centered on Republican. So which means one we centered on the variable that was shown and the output, and the other one we centered on the other one. So take a look at that. So don't forget, if I want to write the model, I need to write the log of that. Okay, so it's gonna be I'm going to consider two model. Okay, I'm going to say okay. You can see there's a cap on the P, the probability of independent, which relative to the Democrats. Take a look at that. Then there's going to be another one, the Republican, versus Democrat. Take a look at that. So all of this guy, they actually gonna come from here. Can you see that? That's super cool, right? So now that is the estimated model. Okay. Don't forget I put a cap. If you want to have a full credit, you have to put a cap because it's estimated. Okay, gotta put a cap. Okay, so the next question now has you to interpret the slope for income in the independent. Don't forget we got two equations. We got the one for independent, we got the one for the Republican. And don't forget, if I actually, interpreted this, interpreting the one for the one that I'm actually seeing, okay, we take a look at the independent, okay, all of these guys, they are in the log odd. They call them log odd estimates. Okay, don't forget that. They call them log odd estimate. So if I want to interpret, I have to mention, say for each unit increase in income, the log odd of being independent rather than Democrat increases by that. If I want to have a better interpretation now, okay, this is for the log odd. So if I want to interpret using the odd ratio, I need to first find the exponentiation. Don't forget, the exponentiation of the log odd will return you to odd ratio. That's what I'm doing here. Exponential raised to power that. So this is the odd ratio now. So if I want to interpret this guy now, okay, I'm actually going to say for each additional income unit, the odds of identifying as independent instead of Democrat increased by 1.62. So I'm actually going to multiply that by 100 whenever I want to interpret odd ratio. Okay, I'm also going to do the same thing to Republican. Take a look at that. Okay, I'm going to do the same thing to the Republican, and I'm actually going to be comparing the predator that actually show in the in the higher output relatively to the one that was referenced. That is it. Take a look at that. Now we just have part one for that. Part two is what if you're given the prediction? Okay, this is prediction probability. Okay, and here they actually they put into consideration if income, the net income equal to one. You know what I mean by one because they have a category for the income. If I actually let me see. uh, in what okay, so in the income less than 3K up to more than 105K. Okay, if you take a look at that. Okay, so if you want to, now they've already used how they came out with this prediction, the probability, putting into consideration certain value of income across board. We want to predict the probability that the party affiliation of the respondent is going to be Democrat, Independent, or Republican. Now you're given this. Now the question now is, explain in a plain language what this predicted probability represents. Which party is most likely choice for a person with income equal to one? This prediction is based on this particular income. When this income changes, this estimated probability also going to change. Does that make sense? So now the question now say compare the likelihood of being Republican versus independent at income equal to one. Okay, so they wanted to do that. So now the solution now, this is interpretation. Okay, a person with the income, you have to mention that income. Okay, a person with the income equal to one, we have, and if you want to interpret probability, it's better you multiply by 100. So that I'm actually going to say a person with income equal to one has a 58.6% predicted probability of identifying as a Democrat. Okay, now the same person with the same, the same, person with that same income, okay, has a 18.4%. Okay, of being identified as independent and as Democrat. I mean, as Republican. So the Republican is giving. Take a look at that. Now, uh, we are having this calculation based on the fact that we consider the income to be one. Okay, so if that actually changes, okay, of course, there's possibility the estimated probability is actually going to change. So whenever you are interpreting probability value, you need to multiply by 100. Okay, your interpretation has to be in percentage. Now, the largest, they say most likely political party based on that income, based on the income, okay, is Democrat because, That is according to our data. And also I said the model predicts that a person with the income equal to that income under consideration is more or most likely to be identified as a Democrat. Now, the next question now has comparing Republican versus independent. If you want to compare that, you actually need to you have to compare them based on the same income. We're still talking about income and what probability do we actually obtain from them. Okay, you can see the probability that we obtain from them. One is 18.4%, the other one is 23%. And of course, that's what we put into consideration here. Now you need to find the ratio. Okay. We need to find the ratio of this probability. Don't forget, when we talk about odd ratio, whenever you want to compare, you can compare the probability, the ratio of the probability associated with a particular variable under investigation related to the other one. And that was what we did here. We divide Republican by independent, and that gives us 1.25. Now, if the ratio give us 1, okay, this is equally likely. But right now, because this is above 1, if I want to have a sense of that, I'm actually going to multiply this by 100. That's 125. So that is 25 above 100. And that's what I'm going to say. So they are about 25% more likely to identify as Republican compared to independents. Okay, do you know what? We just finished the two major areas, the final exam we focus on right now. Which means I just talk about the binary logistic and I also talk about the multinomial. Okay, another area in the exam is going to focus on is a Poisson regression model. Of course, I walk you through this class, through this topic in the last class. I remember we did the same, you know, this is the same question the same example that I use, where you actually want to make a prediction, you want to investigate, what are the factors, that will enable us to predict, the number of customer visiting a store from a region. So you got five predators here. And of course, because we're dealing with a count, you're going to fit a Poisson regression model. Now that has been done. Okay, so if you take a look at, uh, they're actually going to provide you an output. It's missing here, so they're going to provide you an arrow output. Okay, and from the arrow output, based on what we did in class, they're going to ask you to write the model. Okay, this is the feeder model from the arrow output provided. That is missing here, but I give that in class. They calculate the expected number of customers for the baseline, okay, region. I think I walk you through all of this in class. I don't want to waste my time again. And don't forget when they say $10,000 increase, the way we did it in class. Okay, so watch out. Okay, so find the 95% confidence interval for beta 2 for the exponentiation and for the $10,000 increase. Okay, so all of that is actually, you can see the way I did that. So I will advise you go through all of that. Okay, so uh, in this exam, three major questions. Number one, one of them we focus on binary logistic. Another one we focus on multinomial logistic, and another one we focus on Poisson regression model. Now I want to go into problem four. In problem four, we focus on link function, exponential family, and Val-Bantalaffi. Okay. Now you remember in class I walk you through how do we derive the link function from assuming exponential. Oh, somebody want to ask question? I can see that. Go
Yeah,
ahead.
I do. About the previous question, the one about the Poisson distribution.
Yep,
Specifically for problem 6, you give the 95% confidence interval for beta 2. Where does the
yep.
standard error for the beta, or not standard error, or yeah, the uh, standard deviation for beta 2 come from in that interval?
Yeah, if you're looking about the standard error for beta 2,
Right,
they
that
are gonna,
2.11 times 10 to the negative 6.
which one? You said which one?
The 2.11 times 10 to the negative 6.
Yep. Yeah. So this guy here is actually from the table. If you check, I provide in the last class, if you check the lecture material on Poisson regression, you're actually going to see the output that I generated. The output is going to look like a output of conventional linear regression where you're going to have estimate the standard error and so on like that. That is where I pull it out from. Have I answered your question?
Yeah, okay, thanks.
Oh, thank you're welcome. So that is from, they're going to give you the output. The output is missing here, but the output is missing here. Here I only gave data, but it is the same question in the material. Okay, you can check the last material, like I said. So all of that is going to be from the outputs. Okay. Okay. So I want to go to the next question. Like I said, question we sent out on how you can derive the link function from a given probability distribution. This is the link. This is the exponential family form. This is for normal distribution. If the response variable is normal distribution, so how do I derive the link function, and how do I show that it's from exponential family? I did that in class. Then you identify all of this, and of course, you know, this is the link function, okay, the canonical parameter, okay, even though we have others, that we can actually identify based on exponential family. If I were you, we did the one for Poisson distribution, we did the one for binomial distribution, so you can work on all of that. So how do we derive the link function? Okay, so that would be theoretical. How do we derive the link function of some distribution that we've done in this course? Now, the second part, if I were you, the second part is going to be based on Van Bantalafi or the Van Bantalafi and the Francis reparameterization of Van Bantalafi. And of course, that's going to be a multiple choice. Okay, I'm going to say that again. Okay, there's gonna be a multiple choice question that we base on the Van Banter-Laffy growth model and the Francis with parameterization. Oh my God. If you take a look at this guy now, he said the Van Banter-Laffy growth model is this, what does the parameter that represent? Okay. And of course, the parameter is C, asymptotic maximum length. So if I were you, you need to understand what each parameter, in a Van Banter-Laffy model represents. Okay, so we look at another question. This is Francis parameterization. Okay, in the Francis parameterization, the parameter G represent what? Okay, the parameter G represent the ratio of two consecutive growth increments. Okay, now look at another one. They are giving G to be equal to that. Okay, how can you solve for K? Okay, you want to solve for K here. Okay, of course, so that's going to be C. Okay, because if you have if you have this guy given, okay, and I want to solve for this K, I'm going to take the logarithm of both sides. So if I take the natural log, that will be natural log of G, okay, equal negative K into T2 minus T1, right? Minus T1. Then you solve for K. When you suffocate, divide both sides by negative T2 minus T1, and automatically that is going to be C. So I think you're going to have some mathematics, so you need that, okay? Okay, now I'm moving. I want to move right now. I'm actually moving now. Look at that. A major advantage of the Francis reparameterization is what? Okay. They said the parameter become linearly orthogonal, improving estimation stability. Of course, with the Van Batter-Laffy growth model, you saw that when you use different data set, of course, the parameter we have different values or different interpretation. which mean not, if you want to compare the growth, the growth of two different data set, this is not going to make sense. And that is why, um, well, Francis in 1988, actually, reparameterized that. Okay, so, now take a look at this. State and give the meaning of time in Van Bantalaffi growth model. Okay, so if I were you, understand what each parameter represents in Van Bantalaffi growth model, and not only that in the Francis. Okay, so I'm confirming to everyone, we're actually going to have, in the exam, we're actually going to have four major problems that have multiple parts. Okay, four major problem with multiple parts. This is being recorded. Okay, I'm actually going to share my recording. Is there any question? Is there any question?
Yes. Professor,
Go ahead.
can you remind us the final time and the location?
Okay. As at now, the final exam time, the final exam location is the venue of our lecture. But if anything change, okay, if anything change, I'm actually going to let everyone know through the announcement section. Have I answered your question? Have I answered your question? Okay. Somebody said they will see get a sheet. Of course, similar to the final is or to the midterm one and midterm two. So you get a sheet. Or someone said, can you summarize the concept from each question again? Seem like it will be like the practice exam. Yeah. The area that I just covered in the practice exam is the area for the final. So binary logistic, multinomial, Poisson regression, then the exponential family, the link function, the Van Bantalaffi, and the Francis reparameterization of Van Bantalaffi. Somebody said, how much time do we have? 2 hours for the exam. 2 hours, 120 minutes. Okay, 2 hours for this exam. It's final. So yeah, 2 pages, 2 pages of cheat sheet, 2 pages of cheat sheet. Now, I want to say once again, you do not need coding in the exam, in this final exam. You do not need coding. No coding. Arrow output will be generated. Okay, I'm going to say this again. Arrow output will be generated. You do not need a laptop for this exam. You do not need a software for this exam. But there's something that you need for the exam. You need calculator. I'm going to say that again. You need scientific calculator. As of today, because the university actually set this as the date of the exam and the venue of the exam since the beginning of the semester. I need you to pay attention to this. On Monday, December 15, between 1:30 and 3:30 p.m. is this exam. Please pay attention. That is what has been in the syllabus, all this while. Okay, this was set. If there's gonna be any change, I will let you know. But I know there's not gonna be a change to the date. There can only be a change to the venue, to the location. Okay, because I'm actually speaking from experience. Okay, but the exam date doesn't change. It is set. Somebody said, can we expect practical assignment grade before the final? I'm actually going to say this. I'm not going to promise. I'm not going to promise. The practical assignment is different. That one is just to look into a different thing. Okay. So I'm not going to promise. There's possibility you could have it, but I'm not going to promise. Okay. I'm not going to promise. Okay. But there's possibility because today is 10, right? Today is 10 and the final is on 15. So you have 5 days to define it. So you could have it, you could not. But what I what I actually want you to know is if you focus on the areas that I just show you right now, you're actually going to be fine. Is there any other question before I make a final remarks of the semester? Is there any other question? Is there any other question? Okay. At this junction, I actually want to appreciate every one of you for being a very good student. I'm actually going to say this. Uh, you have been wonderful. Okay. You have been so wonderful. I'm actually going to say this uh, uh, we started on a very strong note. Okay. And I actually want us to finish on a strong note. Okay. I just want to, I want everybody, to actually, listen to what I'm actually, uh, going to say right now. Okay. We have concluded this class and, I'm actually, it's a privilege for, prayer or privilege for me to be, your professor, this semester. And I want to say you've been cooperating from me from day one. And all what I'm actually going to say is that keep you know keep doing what you believe or what you believe on. You know, you need to have what I call a strong determination. So, we're all hungry for success. Don't stop. Keep moving. That's what I'm actually gonna say. So, on the final note, I'm actually gonna say as we conclude our final class of the semester, once again, I want to sincerely thank each of you for your hard work, engagement and perseverance. It has actually been a great pleasure teaching you and guiding you through this course. I hope the concept we explored this semester not only strengthen your understanding, but also inspire you to think more deeply, ask better questions, and approach problems with confidence and curiosity. As you prepare for the final exam, remember that understanding is more valuable than memorization, and consistent effort always pay off, you know, and I encourage you to review, thoughtfully what we have covered, the final practice that I just walk you through. Trust the work you have done, and I actually believe in your ability. I am proud of the progress you have all made, and I look forward to seeing the great things, you will accomplish beyond this class. So thank you once again for a wonderful semester. And of course, I wish you success on your finals and a restful, enjoyable break ahead. Continue to stay safe, stay focused, and keep learning. That is all what I actually want to say for now. So keep doing what you know how to do. So thank you all. Thank you everyone. And don't forget to go to student rating of professor. It's on Canvas. The university want to hear from you about the way we'll be conducting our classes. And also you can go to the Google, rate my professor, be honest, say whatever you see. Okay, say whatever you see. And make sure on the final day, come to the final exam some minutes before the start so that you can get settled down before you get started. And keep track of if information on the announcement section. Keep track of the Canvas. We live by information. Okay, those of you that earn extra credit, I'm actually going to as time goes on, when you are done with the final, I'm actually going to put forward an announcement that will ask on how you want to spend your extra credit. So that's so a lot of information will be going out. So once again, thank you so much for being good student. And finally, what I'm actually going to say, the road to success is narrow, and everyone want to pass through the narrow way, going by the accommodating capacity of the road. The road can't take everybody at a time. Some will go, while some will wait. Who are those that will go? Who are those that will wait? That question is left to every individual to answer. But you know what? I remember my friend used to say, the whole world will step aside for a person who know where he's going. If you know where you are going, the whole world will step aside for you. So all what you need a very strong determination. You need to, observe what I call the spirit of perseverance, endurance. Okay. And believe in yourself, even if the whole world is against you. Believe that you are the last man standing in your case. Okay, the whole world is only going to succeed when you join them. Okay, if everyone is against you, okay, it is only when you join them that they're going to succeed. But if you actually stand firm, believe in what you believe, even though the road to that very destination, I don't promise that it's not going to be. I don't promise that it's going to be smooth. It may not be smooth, but whichever way the road, the nature of the road may be, keep moving. That's all what I got. But for now, everyone, thank you. Yeah.